Next, we are going to learn the equation for free fall. Now, what do you understand by free fall is when you release a particular object from a particular height. So that object, what will happen is it will directly be pulled down. Now, why it is getting pulled down is because of the gravitational energy. As the earth has the gravitational energy, and that is why whatever object you throw from a particular height, so it will always reach down because earth pulls it down, and that is the reason it reaches down. So for example, there was one particular object at point A. So this was at the height where it was present. And we have released that object from point A and it reaches at point C. Now we have to find out what things are happening here. So we need to find that what was there at point A. So which type of energy, that is kinetic or potential energy, was there. So that we will find out. So first we will find what is happening at point A. Then that particular object reached at point B somewhere here, and then that we will mark as X. So from A to B we will mark as X. So we will find that what is happening at point B. Then from B that object reaches C. So we will find that what is the total energy at that point of C. So first we will find the energy at A, energy at B, and then energy of at C. A to B we have taken as X. B to C we have taken H minus X. So why we have taken H minus X? Because A to C is H. ये पूरा जो A से लेके जब तक when you will throw the object from A, when it reaches the ground at C, ये पूरा जो है that is H. Okay, so this, if it is X, so this will be what? This part will be H minus X. So B to C will be H minus X. Why it is H minus X? Because A to C, the entire thing is H. The height is H. So that is why B to C, the height will be H minus X. Now let's see what things are happening. What type of energy is there at A, B, and at point C on the ground. So first let's see when the object is stationary at A. So when it is stationary at A, that means no kinetic energy is there. But we need to find both, that kinetic energy was what and what was the potential energy. So first, what we are taking as kinetic energy. Kinetic energy is equal to half mass into velocity square, that is half mv square. But as it is at the initial velocity, it has not yet started to fall, it is initial. So that time we take u. So instead of v, we will take u here. So it is equal to half mu square. Now as initial velocity, जो starting velocity है, that is always 0. So it will be 0. So what we will get is half m into 0, which is equal to 0. So that means kinetic energy is 0. There is no kinetic energy. Next, we need to find out potential energy. Now, obviously, when it is at rest, the potential energy will be there, because whenever the object is at rest, it has the stored amount of energy, which is nothing but the potential energy. So, potential energy will be equal to mgh. So, then we will find the total energy. Total energy मतलब कितना, kinetic energy कितना था and potential energy कितना था. So, total energy is equal to kinetic energy plus potential energy. Kinetic energy we got as 0, so we will put here as 0, plus our potential energy is mgh, so we will put here as mgh, that is mass into gravity into height. So 0 plus mgh, we will get mgh. So when the object is at rest, that is when it is at point A, it is not yet started to fall, that time the total energy is mgh. Next is when the object reaches at point B. So when the object reaches at point B, that means it is moving. That time we are taking height as x here. So we can take x, that is displacement jo tha, that time pe it is x. If some type of displacement took place, so that we are taking as x. Now here velocity as initial to final we can take as vb. That is, it is reaching at point B, so we can take final velocity at B. So we can write it as VB. And the distance that was covered, we are taking as x. So U is equal to 0, that is initial velocity is 0, S is equal to x, and A is equal to G. Now why we are taking A as G? Because here gravitational is acting. Gravitational force is acting and there is no acceleration which is taking place. So that is why we are taking A as G. We will use Newton's formula, that is V square is equal to U square plus 2AS. Now V square here, V is what? VB. So we can write VB, that is final velocity at point B, square is equal to initial velocity. We all know that it is always 0. So we have taken here 0 plus 2. Now instead of A we can write G. So we have written here G. And instead of S we can write what? X. So we have written here X. So now what we get is VB square is equal to 2gx. This we have got. Next is, now we need to find that kinetic energy. Kinetic energy is what? Half mv square. V we are taking as B, so we can write VB square here. So half m, what we got? B square was 2gx. Okay, 2 and 2 got cancelled. So we got that KE is equal to mgx. So when the object is at point B, our kinetic energy is what? mgx. Next we need to find out the potential energy. So when the object is at the point B, that time here, so we can write PE is equal to mg h minus x. That will be our height. That is when you will minus x from h, we will get that particular height. So mg h minus x, that we can write. You will multiply inside, that is mg, we will open the bracket and we will multiply mg into h and mg into x. So we will get mg h minus, when we will multiply mg into x, we will get mgx. So here when the object is at point B, our potential energy is what? mgh minus mgx. Next we have to find the total energy. Total energy is nothing but kinetic energy plus potential energy. Kinetic energy, what we had got here? mgx. So we will directly put that kinetic energy is equal to mgx plus what we had got potential energy here? mgh minus mgx. So we will put that value mgh minus mgx. Now what you can see that this is plus and this is minus. So plus and this minus will get cancelled. So mgx plus minus mgx will get cancelled and what will remain is mgh. So what we found that total energy at point B is mgh. Earlier what we found that when the object was at A, total energy was mgh. At point what we got? That when the object is at point B, that time the total energy is mgh only. So that means A also and at B also total energy was same. Next we are finding what will happen when the object reaches at point C. So from A we have released the object and the object has now reached C. So here the final velocity at point C we can write as Vc. U, that is initial velocity, will be 0. S, that is the displacement which had taken place, that will be h, because here we have taken h, it is falling from a particular height. And A we have taken as g. Now why we are taking A as g? Because here gravitational force is acting. We will take Newton's third law of equation, that is V square is equal to U square plus 2AS. This is Newton's third equation of motion. Now instead of V square, we can write Vc square. So we can write, instead of V square, we will write Vc square is equal to U square. U, that is the initial velocity. Initial velocity is always 0. So here we have written 0 plus 2. Instead of A, we are writing G. So instead of A, we will write here G. And then instead of S, what we are writing? We are writing H. So instead of S, we can write H. So what we got? That Vc square is equal to 2gh. Now we will use kinetic energy formula. Kinetic energy is equal to half mv square. Now here instead of v square, we are writing Vc square. Now instead of Vc square, what value we can put? We can put 2gh. Here we have found out that Vc square is equal to 2gh. So instead of this Vc square, we can write 2gh. So what it will be? It will be half m 2gh. Now 2 and 2 will get cancelled. What will remain is m, g and h. So kinetic energy here is mgh. So that means when the object reaches at point C, we got that the kinetic energy is mgh. Now, we will calculate the potential energy. Now, when the object reaches at point C, there is no height. So that means height will be equal to 0. As it has reached the ground, जब वो ground पे touch हो गया है, so that means there is no height which is acting on it. So that means height we will take as 0. So H is equal to 0. Potential energy is equal to, we know the formula, mgh. H is nothing but 0. So mg into 0 is what? 0 only. So that means total energy is equal to kinetic energy plus potential energy. We have found out potential energy which is 0, kinetic energy which is mgh. So we will put kinetic energy is equal to mgh plus 0, which is nothing but mgh. So that means total energy when the object reaches at point C is mgh only. So from this what we came to know, that when the object was point A, when the object reached at point B, and when the object reaches at point C, at all the points the total energy is equal, that is it was mgh only. So when the object is released from point A and it reaches to point C, all this time the total energy was equal, that was mgh. So total energy is always equal at all the points. So from the expression of free fall, we came to know that total energy of any object when it is released from a particular height is always same. If you calculate it somewhere here or calculate it somewhere here, so at all places the total energy will always be equal only. This is the derivation for free fall. Next is power. Now the power differs from person to person and from object to object. Each person has its own amount of power which is there. Your father won't be able to climb the stairs as fast as you can because he has less power than you. So if we give same work to two different people, the time taken to perform the work will be different to each person. So the fast or the slow rate of work is done is called power. Power, you can also say that power is the rate at which work is done. It depends on two things, work and time. So we can also write that power is equal to work upon time. In short form, you can write P is equal to W upon T. Now in SI system, work is joule. So if you need to write the unit in SI system for work, it is joule. And for power, it is joule per second. We can also write it as watt. 1 watt is equal to 1 joule per second. You can also write joule per second or watt. So 1 watt will be equal to 1 joule per 1 second. Now in industrial sector where we use a lot amount of power, there it is measured as horsepower. 1 horsepower is equal to 746 watt. And in commercial sector, that is at our homes and all, we use the unit as kilowatt hour. Watt is equal to 1000 joules. So if we have to find kilowatt, it is 1000 joules. So if we need to find 1 kilowatt hour, so it is 1 kilowatt into 1 hour. 1 kilowatt is 1000 watt. Multiply by 1 hour has 3600 seconds. If we will multiply both, we will get as 36 lakh joule. This we can write as 36 into 10 raised to 6 joule. So 1 kilowatt hour is equal to 36 into 10 raised to 6 joule. This is the one unit, that is 1 kilowatt hour is just the one unit. And it can be used in the electrical purpose, in our domestic purpose, that in our houses or in the nearby places. But this amount of power we don't use in the heavy industries. In large industries we use horsepower because there more amount of power is required. So with this we complete our second chapter in Science 1, that is work and energy. We learned about work. We learned about different forms of energy, kinetic energy, potential energy, transformation of energy from one form to another form, law of conservation of energy, and various equations, or you can say the expressions for energies. I hope you all have understood. Thank you for listening. Bye-bye.